In this video we're going to take the simulation that we've done in the last few videos of the house exploding and the pyro, of which I've managed to render now. So if we have a look at that, we can see it explodes quite nicely. And we did everything inside SOPs without having to go inside DOPS at all. The advantage of that is I could treat everything separately. The disadvantage is we had to do a few tricks to make them look like they were coherent. So in other words, looks like the explosion caused the house to blow up, even though we blew up the house first. So we did a trick with the sourcing and stuff. So what we're going to do now in the next couple of videos is we're going to actually dive inside DOPS for the first time, and we're going to see how we can take this a bit further. And we're going to look at some of the other custom tools with the rigid body solver. So in the first video we'll look in the rigid body solver and look at how we can improve this explosion by creating a sense of how these materials are fitted together, so some kind of structure to the roof and the wall, so they don't just pop open like this. And then in the next video we'll look at how we can add custom microsolvers to the smoke to get more control over the noise in it. So let's have a look at how we can fix the simulation here. So back having a look at the simulation, I'm here at the rigid body solver node, and the first thing I want to change actually is if I go to the solver here, I just want to drop the collision padding down by an order of 10. This just makes the collisions more accurate and stops the bullet pieces rolling around in a strange manner when they hit the floor. So I just want to drop that by an order of 10. But the main thing I want to do is just to remind us how we got this thing to work forwards. And what I mean by that was we animated this overwrite attribute, which is a bit hacky. You know, we transferred in the velocity here, and what that meant was we're actually overwriting the velocity. So every time we're transferring it in, we're actually overwriting it from the sim, and these pieces are just going to move with that velocity field, not forward gravity, which looks a bit weird. So we had to animate it off just after the explosion started, which meant we missed a large part of the explosion. But it kind of worked for what we needed. So the first thing I'm going to do is going to get rid of that. So I can just get rid of the V here to not transfer that in, and it doesn't matter about overriding these attributes because they're just states. But just for sake of completeness, I'm going to right click on the animation here and just delete the channel. And that means this velocity is no longer being read in, so it won't work. In fact, I'm going to bypass it entirely. Oh, that was the wrong chain. Let me just bypass that. So we'll see the attribute transfers not being used at all. So if I was to press play now, the thing would just, the glue constraints would still collapse. If you remember, we've got them with this expression here with the impact, so they'll still break, but there's no force to push them out. I won't flipbook that to show you, but what I will do is show you how we can add custom forces now to change this. So I'm going to dive inside this solver, and I can add nodes in here now. And what I'm going to do is, it says here we can add pop forces in. If we hit tab, the pop force, if you type pop, these are all the pop tools, the particle tools, and basically the packed primitives, since they're points, can be thought of as particles. So you can use most of these tools with your rigid bodies, which is pretty cool. So you can make them move along a curve, that kind of thing. So just to demonstrate that, let's do a pop wind. So let's type W for wind. Let's pop wind in, and we can just give it a direction, say 10 in the X and maybe 2 in the 2 in the noise, so we get some noise in there. So if I just run the simulation now, remember around frame 4 or 5 we'll get our force coming in and adding some impact and breaking the glue, and then this wind force will kick in and it will blow off our pieces off to the right here with noise in there, and already you can see the house is starting to move with that direction. So you can add lots of forces here and really customize what goes on. It'll even respect particle streams, so you can do interesting stuff with streams there. Which I'm not going to demonstrate, so let me just turn this off for a minute. If you want to combine multiples, you can add a merge in here. And what I'm going to do is I want to attribute transfer back in that velocity to these pieces again. So if you remember, up here we transferred it into the proxy geometry, which is the geometry Bullet uses for simulation. So we want to access that. So at the moment we're actually inside DOPS, and this is not the SOP network. If I want to, say, use my attribute transfer, you'll see there isn't an attribute transfer node. So what we've got to do is just understand a little bit of how DOPS works in order to know what to do. If we look at the spreadsheet, we can see actually that it's not like a normal spreadsheet. We have our rigid body objects here, but this is like a list of data about these objects. It includes, if you click on geometry here, the SOP geometry. So this is the stuff we're interested in, the bullet data. So basically, inside DOPS, when you create a solver, what a solver does is it edits this data frame by frame, which means you can update it and change the simulation. So we want to change the SOP geometry here. So for that, I want a SOP solver. So let's make a SOP solver. Let's put it in the merge. So the merge is important, actually. The order that you plug them in is the order that they occur. They do the maths. So Houdini always works from left to right. So we'll do the win first and then the solver. What I'm going to do is actually swap those around. So we'll do our solver first from the explosion and then maybe some win second. Don't think it makes too much of a difference, but it's an important thing to know. Well, it will in some cases, but it's an important thing to know that the order that they're plugged in is the order they get processed in. So the SOP solver will allow us to edit this SOP geometry frame by frame. Now if you go inside it, this is actually a SOP's context. And if we do our attribute transfer now, we'll see we do have that node because this is a SOP's context. You may notice it may or may not update here. Don't worry about that. This is bringing in the geometry from the simulation. In other words, the bricks and stuff. And look, we can see the attributes there on it. Since we're in SOPs, what I want to do is use an object merge node. And what this will do, this will bring in our forces out node. Now remember, we gave it an uppercase name, forces out, which we could find here. But actually, let me show you a slightly different way. This is the node we want to connect to, forces out. If you do Control C, to copy the node and go back into your SOP solver, in here in the object merge, you can just do Control V, which will just type the path in, saves you having to browse. Or you could use the browser and the uppercase letters will make them appear easily. The other thing you could do, actually, if you know what you're looking for, is just start to type it. So force star forces out. Ooh. Hello, has that gone funny on me? Yep, the window seems to have jammed up there. Right, let's try that again. So yeah, if you start to type that force star, you see it filters the list, and you get everything that begins with forces out. So you can search for stuff on a big list using that filter. The other thing you must remember to do is turn on this into this object. That'll bake down any transforms and make sure it's in the correct place. So let's plug in our DOP geometry and our object merge and use our attribute transfer. And what I'm going to do is just transfer in the velocity here. And you'll see it's picked up the geometry because it's got the attributes there, even though it's not displaying it. And on the conditions here, let's try maybe a distance of 5. I know we used 3 on the other one, but we'll try 5 here. And let's put a null at the end, just for sake of completeness. We'll call this out. So let's turn that on. So what this will do now is transfer that velocity in, but it'll do it frame by frame. So it'll happen whenever the explosion occurs, so we don't have to worry about keyframing, and it'll properly add it into the simulation rather than overwriting it. So if I just flipbook that now, and I'll pause the video while that occurs, we'll see hopefully the house will explode based on that force being transferred in. So I'll just pause the video while that flip. After running the flipbook, I can see the explosion is working, but it's not very strong. So if you remember, up here in the point wrangle, we could scale it. So let me put about 0.5 in there. Let me maybe shrink in the SOP solver here this attribute transfer down a little bit. Maybe let's put 3 back in. That's the same as the original setting we had here, but I've increased it to about 0.5. So what I'll do is I'll just flipbook that up again just to check that looks good. So I'll pause the video once again. There we go. That's let me just cancel that actually. So if we look at that now, that's looking much better, and I can control that just by amplifying it up again with this multiplier here. So I'm pleased with that for the moment. So the next thing I want to do is control sort of how the things break apart, and the glue constraint's got a nice property. Let me just come up here, let me just make that big and tap P again. If we come up to here, the where we created the constraint properties, particularly the roof tiles here. So these are all the roof tiles that we're applying. I'm actually going to copy that group, you'll see why in a minute. And I'm going to turn this on, switch constraint type when broken. And it's going to switch to this, a soft constraint. So this is the bullet soft constraint, and this will give us a sense of ductility when the thing explodes. And what I mean by that is it will kind of connect them together with springs. So when the glue breaks, these guys will be connected together with springs. Remember, this is all the tiles to all the tiles. And then what we'll see is there's some kind of sense of structure, like they were pinned to some wooden struts. I should have modelled the wooden struts in there and constrained them to it. So there we go. If we jump to that frame, you'll see that all the tiles are held together by these springs, which has given us quite a strange effect. But what we can do with those springs is we can tune them. So the first thing I want to do actually is increase some of the softness here. Let's make them a little bit stiffer, something like 10,000. That just means they won't stretch out so far when it initially explodes there. You know, they'll be a lot stiffer and we won't see so much of the rotation there. So let me just run through a couple of frames just to see how that looks. Let me just stop that there. Let's go to this frame here that's cached. Let Houdini update itself. There we go. And you'll see they don't stretch so far apart. And it's given us, I'll probably have to increase the force to push that off higher. But you'll see it's given us an interesting sense of the structure there. It's like they're still riveted to stuff. So what we can do is, maybe let me bring that down a little, sort of stretch a little more. So what we can do is we can set up the solver to break that, and it essentially is using one of those SOP solvers internally, but we can do it automatically here in this tab. This is in the Constraints tab in the Breaking Thresholds tab. And remember, we were breaking all constraints called glue here with this condition. So we can do this for any constraints that we've made. So let's click plus, and let's click on the second tab, and I'll get rid of the word hard. Now it's using this word soft. If you remember, let me come up here again. On this node, it's creating a constraint called soft there, so it needs to be the same name. So in here, it's got the same name. And what you can do is, the reason I copied the group before is to paste that group in here. So look, it's going to affect just these objects. It's going to look at those objects and only affect the soft constraints on those. So if I create other soft constraints, it won't. These settings won't affect those. They'll literally just affect the ones on the roof here. So this is the way we can partition stuff up and get that high level of control. So the way we can break it is, let me just jump through to a couple of frames, is each constraint type has their own attributes. As you saw, we use the impact attribute for glue in order to break the glue. And for the soft constraints, there's a couple that we can use. There's torque and angle. So let me just run this through for a little bit. And if I just pop in a null, we can plug in the pink one. Remember, that's the constraints, and there we can see them here. And if I right click and go to the spreadsheet, remember that's primitive, so we want primitive attributes. You'll see if I click on view here, there's a whole bunch, but we've got, where is it, torque? There it is, torque, and we've got angle. So we can filter the list and see what kind of numbers we're getting. So let's type angle and torque. And you can use either of them. So there we go, we can see kind of the numbers that we're dealing with. Torque's going between sort of 1,500, and the angle is anything up to 0.17. So this tells us these numbers, so we can use that. Well, if we go back to where the sim started, you'll see these attributes don't exist when the glue's there, but as soon as the glue's broken, the new constraint appears and we're seeing stuff. So they're 1500 and about 0.2 for the angle. So the torque's anything up to 1500. Remember, that's the maximum value. Might not be the majority of them. So in here, what we can do is turn on torque, and what this will do, it'll, let me go back to frame 1. The clue's here, delete constraints. Rather than, we could switch to another one if we wanted, but we want to just delete. And we can put in a number here. Let's try 50. Let's try something a bit low. So let me just jump forward to frame 7 and let the sim catch up with that. So basically, any of these soft constraints that are above this value will get deleted, because we told them here, and they'll basically break. So you can create your own, there we go. So we'll see some of them have broken and some haven't. If we actually look at the geometry, let me turn on the solver itself, we'll see we're still getting some sense of the structure there, where some of the tiles have clumped together and others haven't. And it just gives a sense, like I say, there's some kind of some structure to it, really. And look, now they're starting to break apart. If we have a look, we'll see they're a lot shorter. And if you really want to break them all at once, you can actually turn on at frame, and then at this frame they'll all disappear. So if you want them all to suddenly fall apart once they're a bit further on, you can do that. And again, you can scale this by attribute or add a variation to there. So maybe we'll put 100 in, we'll have a variation of maybe 50% either way, and we'll see what that gives us, which is quite handy. And you can write vex expressions to control these and add more randomness if you wanted to, but the randomness is built in here, which is quite nice. So we'll see again how the glue's broken up, and you'll see we're getting more structures in there. For the roof tiles, it's not really what I want. I don't want these to hold together. I do kind of want them to separate. So what I'll do is I'll just turn off the variation, or the variance, and then we'll put that back to 50. So that's my roof structure. What I'd like to do maybe is also do the same for the bricks here, have some of these clusters hold together on the bricks. So let's find the brick constraint properties. Here it is. So again, let me copy these brick names here with Control C, and we'll switch that to a soft. And again, we'll make that quite stiff before it breaks apart. And then we'll come down here again, create another tab. Again, we're dealing with soft constraints, but again, I'm going to use the groups here to partition them. So that's only going to affect the ones in the brick there. And we'll make the brick maybe a bit stiffer, so 100 before it breaks, rather than that 50. So again, let's jump forwards, and hopefully we'll see a bit of stretch between the clusters in our brick here before it snaps apart. I could make this cluster smaller and we'll see more of that stretchiness, but then again, this thing explodes in a couple of frames. We just want a suggestion of that structure. So if I just let that run forwards a bit more, we'll see most of that's, well, all of that's in fact broken up. If we go back a couple of frames, let's check the see when the constraints disappeared. So you'll see some of them stay together. They didn't quite break. Maybe I could bring that down. But we've got quite big clusters there, so that's okay, I think, for this. But look, we get some better sense of it holding together before it breaks apart. Might need to increase our forces there. Last but not least, I might just try the same for the wood. So I'll just do all the all door constraints rather than the wooden frame. So yeah, let's copy all of that, and again we'll switch this to the soft constraint, and again we'll make that quite stiff. So last but not least, we'll click a plus in there. Again, we'll get rid of the hard, give it to the group here, and again we'll give it maybe a little bit of a torque there, something like this. Again, let's forward the simulation and see how that breaks. Glass doesn't really stretch, that does just pop and shatter. So I'm not going to add glue to the soft to the glass, but it's where you kind of want to suggest, you know, there was some structure holding it together or some forces. So look, there we go. That's probably a bit too much because, well, that's all right, maybe. Not too much of it's held together. I think if we go forwards more, so you see there was a sense that the door had some structure before it broke apart. It didn't just disintegrate its splinters in a more reasonably controlled method there, in controlled way. So if we run forward, you'll see the door looks a little bit better there. So we can go around and fine-tune a lot of this with the soft constraints there. So one last little flipbook here before I, in fact, yeah, one last little flipbook here before I cache it out. So I'll just pause the video while the flipbook occurs. There we go, the flipbook has occurred, or at least enough to know that that's worth caching out. So I'm liking that. I can see the door blowing out as a door before it disintegrates into shards. You can see the bricks have some kind of chunkiness to them, and the roof has that kind of structure just before it disintegrates into the air there. So I'm quite happy with that. That's the point. I'd like to cache this out. So I'll just select this guy here. Remember, I need to set a rest position, and let's call this points soft or something. Obviously you're going to use a much better naming convention than me, and I'm going to save that to disk. Now that that's banked, if you remember, I'm going to have to recache the collision objects, which is going to take a bit of a while, and then I'm going to have to redo the simulation. So I'm not going to recache the simulation now. What I'll do is I'm going to stop the video shortly, and then I'm going to recache the collision objects. There we go, that's all simulated. So let's go load from disk on. So here we go down to the house object now. We should see our new simulation carrying through. There we go. We can read it in quite quickly because remember, we're just copying in the points now, and we're transforming the original geometry there, if you remember. So why that's cooking the pyro, I don't know. Have I got any templating on? Not really. So yeah, let's just jump forwards, and you'll see the house explodes quite nicely. So what I'm going to do now is, as I mentioned, I'm going to come up here because this is the next bit. We want to write out the collisions for our pyro. So we'll call this soft as well, just so I know it came from that same setup. And let me just save the scene. So I'm going to do that in a moment, and I'm going to stop the video. So in the next video, we're going to look at the pyro solver here, and we're going to add custom microsolvers internally so that we can really control the noise that we see in the smoke and other stuff. So we'll get that much finer grain control. So I'll stop the video, and I'll see you in the next one.